So welcome to the integration by parts practice video. We're going to get some good practice with the integration by parts concept that we built up in the previous two videos. So let's start with this problem right here. So I'm thinking about these steps here, my u choice and my dv choice. Whichever one has the simpler derivative, that will be my u. So this could be u, or my e to the negative x could be u. Now which one has a simpler derivative? Well, the derivative of the x squared plus 1 is just 2x, and the derivative of e to the negative x, remembering your chain rule, that's going to be negative e to the negative x. I think this one is the simpler one. So I'm going to go with this choice for u, which makes the e to the negative x as well as that dx my dv. So let's see where that takes us. So here's my u choice, and I want to take the derivative of it so I can get my du by itself, because I know I'll need it here in my second integral. So I'm going to multiply both sides of my derivative equation by dx. Got it. And I'm going to take the antiderivative of both sides of my dv choice so I can figure out what v is. And that gets me v as negative 1 times e to the negative x. So I got my du and I got my v. So if I execute my integration by parts recipe, that will get me here. So I look at this integral, this second integral here that hopefully is going to be easier. It looks kind of messy right now. Let me take out this negative 1 and factor out this 2 here. Alright, so that looks a bit better. So I'm taking a look at this integral here, and it doesn't look nice. It definitely doesn't look like a simple inverse power rule, like antiderivative of x squared is simply x cubed over 3. It definitely does not look as nice as that. So I'm thinking, what sort of integration technique should I use to take this down? So if I think of u sub, I don't think I see anything that could be a u, and I don't see the derivative of that u. Like if I made u my negative x, that would be my u here, but my derivative step would not be able to replace this x here. So u sub will not work on this one. So the only other advanced integration technique I know is integration by parts. And that's what you actually have to do. You have to do integration by parts on this integral now, and this happens a lot. 2 integration by parts in a row. So what to make u and what to make dv? Well, I think my u will definitely be my x, because the derivative of x is just 1, which makes dv the e to the negative x times dx. Alright, so let's execute this second integration by parts with these choices. So my u is my x, and my derivative of it is pretty simple, so that checks out for my step 1. Of course, I want to get du by itself, so I multiply dx on both sides to get me here. Very nice. Got to do the antiderivative of both sides here to get my v. So if I'm sharp with my u substitution, I'll get this as my v. So I'm all ready to crunch the second integration by parts for this guy right here, so let's do it. So here's my second integration by parts. Again, for this second integral right here. And if I look at this integral, this one looks a lot easier, so that's great. Let me just take this negative outside here real quick. To simplify, it's always a good idea to simplify. Alright, so I see this integral right here, and this is just a u substitution. This is just chain rule in reverse here. So I know this antiderivative will be not just e to the negative x. That's what a lot of people say. You got to be careful for that u sub, that inverse chain rule. It's negative 1 times e to the negative x, then plus c. So this right here is the answer to this antiderivative right here. So what I have to do is take this entire expression and plug it right in there. And we have to be very careful here with our algebra. So the answer to my main question, let's just bring our work down here, will equal all this stuff brought down, then plus 2 times this entire expression right there. And that is it. That is the answer. Of course, we could simplify it a bit by filling in our 2. And we'll get this. And of course, the plus c integration constant just remains a c. It's just a constant. It could be any number. It's not a variable. So this is the answer to our initial integration problem. So be on the lookout. Sometimes you have to do integration by parts twice. You have an integration by parts inside of another integration by parts. Alright, let's do another one. So before I forget, we're purposely ignoring the bounds here. I don't want to... Dealing with definite integrals isn't hard, but the main thing I'm teaching you is how to use these special integration techniques. So that's why we're not concerned with doing the definite integral bounds. That's just one extra step on top of the integration techniques that we're really focusing on here. So this problem looks like a weird problem because I don't even have two equations getting multiplied by each other. Integration by parts is the inverse of product rule, which means we're looking for a product of two equations. Well, actually, I can look at this problem as two equations getting multiplied by each other if I look at it in this way. Alright, so now I have that multiplication of equations going on. So which equation do I choose as u? Well, which one has the simpler derivative? Well, derivative of my natural log of y, that's just 1 over y, so that's not too bad. Now the derivative of this thing, well, that thing looks gross, so watch me ungrossify it. Remember, radical of anything is just that something to the 1/2 power. And whenever you have a power in the denominator, it really looks like this. So just remember those rules of algebra. They're there to help you simplify stuff. So the derivative of this guy is just a simple power rule. Bring down my 1/2 and y to the negative 3 over 2. That's negative 1/2 minus 1. Alright, does this thing look simple? Definitely not. So I think I'm going to choose my natural log of y as my u, which makes the 1 over radical y as well as that dy or dv. Remember, the dv has to have that differential in there, whether it be a dy or a dt or a dx. Alright, so I'm going to differentiate my u. That gets me a 1 over y. And of course I want to multiply both sides of this equation by dy so I can get du by itself, because I know I need to substitute something in for that du. So let's do that. And now I need to antiderive my dv to get my v. Notice how I chose to look at this equation in its simpler form, y to the negative 1/2. And to antiderive it, that's simply an inverse power rule way of thinking there. Alright, now that I got my u, my du, my dv, and my v, I'm all set to crunch my IBP recipe, so let's do it. So there we go. So let's pray that this second integral is easier, because that's the kind of the whole point of integration by parts. Transform a tough integral into a easier integral. So let's see how we did. Honestly, this integral looks gross. That's okay, let's try to simplify it at least. I'm going to bring this 2 outside for starters. Okay, and this thing can be simplified. Remember, this is just y to the 1/2 over y to the 1. When you divide numbers that have the same bases and different powers, you subtract those powers. So we end up with y to the negative 1/2. Alright, so that thing cleans up pretty nicely, actually. Okay, so for this integral right here, it's looking a lot more bearable. Doesn't look like I need an advanced integration concept. Doesn't look like I need u sub or another integration by parts. Looks like a simple inverse power rule will do. So if I undo the power rule, we'll get this. Alright, so instead of writing this integral, I'm going to write the answer to that integral, what that integral actually is equal to, once you carry out that integration. Alright, so there we are. So now just a little cleanup, and that'll be that. So let's FOIL in this negative 2 in here. And we'll end up with this. Alright. Let's do one more. Alright, so this one looks like one of those problems I warned you about in the part 2 integration by parts video. Looks like we just have one equation right here, so I'm just about to make this my u and this my dv without a second thought. But you got to be very careful. We do have two equations getting multiplied here. Natural log of x times natural log of x. Remember, that's what this squared really means. So it doesn't really matter which one I make my u. They're both the same, and the derivative of natural log of x is 1 over x. Well, let's imagine the dv. Of course, the dv will also be natural log of x. Well, does a natural log of x have an easy antiderivative? And I would say no to this. Not quite a super antiderivative. It's definitely not an easy inverse power rule like we're hoping for. So I'm going to choose this whole thing as my u, which makes this guy my dv, like we discussed a second ago. Because it looks like from this point we don't have any other choice here. Alright, let's see where this takes us. So here's my u. I take the derivative of it. It does not look nice, but we're going to see what happens. Of course, I'm going to multiply by dx on both sides. Gets me here. And of course, with my dv choice, I need to do the antiderivative of both sides. That'll get me a v as x. So I got my du, my v, and my u. So I'm all ready to go. So if I do my integration by parts recipe, I will get this. The second integral does not look nice, so let's clean that up. I can bring my 2 outside. And actually this x and 1 over x will cancel out. So now we're left with this. Which kind of sucks because in the very beginning, when we were considering splitting up this problem into natural log of x times natural log of x, we were faced with doing the antiderivative of this natural log of x, and we didn't want to do that, so we made these choices, but we ended up with the natural log of x anyways. We have to try to integrate this anyways, which kind of stinks. So I'm really thinking about how to do this. I don't see a u sub. I don't think anything I don't see anything that I could make an inside, and I don't see the derivative of that inside anywhere else. So the only other technique we could use is integration by parts again. And there's literally only one equation here. So this has to be our u, which makes this our dv. All right, let's see what the integration by parts does for us here. So here's my u. I take the derivative of it. I want to multiply both sides of this equation by dx to get du by itself. Of course, I'm going to anti-derive both sides of this equation to get up to my v. That's as simple as v is equal to x. Alright, so let's chug our second integration by parts here and see what we get. So hopefully you can see that. So thank the gods, this integral is a lot easier because check it out, these x's completely cancel each other. So this second integral turns into just the integral of dx, which of course we know to be x plus c. Alright, finally we ended up somewhere. So the answer to our question, what is the integral of natural log of x? Well, that is this. And of course we want to just take this and put it right here. And then our final answer will be assembled. Alright, so the hard work is done. Now we just have to follow through and not mess up with the algebra. So there I go. I just replace this entire thing with this guy. And that is that. We can do a bit of simplifying for all this negative 2 in. And there we go. This is our final answer. Alright, so hopefully you got some good experience working out some integration by parts problems. These were some tough problems actually. So if you're able to follow the work here and understand and see the concepts at play here, even though all this stuff was so convoluted and sort of gross, good for you. If you were able to still see that basic integration by part concept at work. Remember, just got a recipe right here, and it's all about choosing the u and the dv, so that our second integral here is easy.